In this session, we're going to discuss factoring. In particular, we're just going to talk about factoring basics, or GCFs. Alright, so we're going to talk about factoring basics. Okay. GCF. GCF standing for greatest common factor. Greatest common factor, GCF. Alright. Now, when we're talking factoring, the easiest way I can put it is to say it's similar to division in that it's like undoing multiplication. So let's say we had a problem like 12x to the 5th plus, let's say, 8x to the 7th minus, let's say, 6x to the 4th. Okay, we're going to take that and we're going to divide it by, let's say 2x to the 4th. Okay, so our dividend, okay, is the polynomial at the top. Okay, so the polynomial at the top, dividend, and the monomial at the bottom that we're dividing the numerator by. The numerator is the dividend, the denominator is what we call the divisor. Okay, so that's what we're dividing by. Alright, now, so if we were doing this particular problem, it would be similar to just dividing each term in the numerator, each term in the dividend, okay, by our monomial divisor. Alright, so we would first look at the coefficients and we'd say 12 over 2 is going to give me a 6. I have x to the 5th, x to the 4th. At 5 minus 4 is 1, so that's x to the 1st, which is just x. Write my plus sign. 8 over 2, excuse me, is 4 when you divide. X to the 7th over x to the 4th. 7 minus 4 is 3, so x to the 3rd. And then you write your minus sign. 6 over 2 is 3. X to the 4 over x to the 4. 4 minus 4 is 0, so you wouldn't have any x's to show for right here. And this would be your answer, your quotient, right? Okay. Now, if we were talking factoring, what we're saying is if we're given the same problem, okay, instead of dividing, now we're talking factoring. Okay, this right here is all an example of division. So if we started with the same problem, factoring wise, okay, the difference between the two is in factoring I'll just be given some polynomial to try to factor, whereas in division I'm given a polynomial, a dividend, and I'm given some type of polynomial to be used, or a term to be used as a divisor. Okay, the difference between the two is I don't have a divisor for factoring. Alright, it's not written in fraction form. You're just given the polynomial, and basically for factoring what you have to do is you have to determine what the divisor is. Alright, so you have to figure the divisor for yourself when it comes to factoring. So the way this goes is I first I want to check coefficients. Okay, first I want to check the coefficients. So I want to look at 12, 8, and 6. Those are my coefficients for my terms and my polynomial that I'm presented with, that I'm told to factor. And I'm trying to figure out, is there a factor, a number that goes into 12, 8, and 6 evenly? And what is the biggest number, the greatest factor the greatest factor that 12, 8, and 6 have in common, thus GCF. Okay, so looking at these, I have a 12 and a 6, so immediately I think 6. Okay, I know 3 as well for 12 and 6, but I have this 8, and 3 won't go into 8, and the 6 won't go into 8 evenly. So now I'm talking 12, 8, and 6. 4 looks good for the 12 and 8 because I know 4 goes into 8 and 4 goes into 12, but 4 doesn't go into 6 evenly. Alright, but what I do realize is that all of these coefficients are even numbers. 12, 8, and 6, they're even numbers, and I know that 2 goes into all even numbers. Okay, so now I found the coefficient part of my divisor, 2. Now after I check the coefficient, then I want to check my variable. Okay, again, this is the process for factoring. Now we know division, we did division in the previous lesson, so now we're focusing on factoring. I'm just trying to get you to understand that factoring is pretty similar to division. The only thing is you have to figure out what your divisor is, and once you figure that out, then it becomes the same as division. It's just we write it out differently. Okay, so I noticed that x is present in this first term, x is present in this middle term, and x is present in this last term. Okay, so x is present in all 3 terms, so that means I can pull an x out. Alright, the fact that it's present in each term, x is present in this first term, right here, x is present in the middle term, right here, and x is present in the last term, right there. Okay, so x is present in each term, so that tells me I can pull an x out. So now once I determine that I can pull an x out, I check my exponents, and whatever the lowest exponent present, that's the exponent that I pull out. So I have an x to the 5th, x to the 7th, and x to the 4th. So since 4th is the lowest, I pull out an x to the 4th. Okay, so if you see, once I've checked for my coefficients and variable, I really found my divisor. Okay, but now instead of calling it a divisor, now we're calling this, when we're talking factoring, we're calling this a GCF now. Okay, so we know that if we divided the 12x to the 5th plus 8x to the 7th minus 6x to the 4th, if we divided that by our 2x to the 4th, we would get this answer. Okay, but we're not dividing now, we're factoring. So what we do is we pull out our GCF, once again, our 2x to the 4th now, which would have been considered a divisor for division. We pull that out and we write what would be left if we took that, factored out the 2x to the 4th from each term. So if we factored the 2x to the 4th out of this first term, which is 12x to the 5th, the 12 divided by the 2 would give me a 6, x to the 5th, pull out x to the 4, that'd give me x. Okay, then I look at pulling 2x to the 4th out of this middle term, that'd give me a plus 4, x to the 3rd, and then I pull out 2x to the 4th out of this last term, which will give me a minus 3, because the x's will cancel. So notice what we got for our quotient, we're actually writing it as multiplication with our GCF, right? Because we have our GCF, and then in parentheses we had what would be left if we divided our GCF or factored out our GCF from the initial polynomial. So this would actually be our answer. Okay, alright, where this is the GCF and this is what's left. Okay, now when we're talking about factoring, again, we're trying to find the greatest common factor that can be pulled out after checking coefficients and checking variables, right? And once we pull out, again, we're writing what's left in multiplication form. And the reason why we write it in multiplication form is because we're saying factoring is like undoing multiplication. So in other words, if I took my answer, again, this is my answer here. If I took my answer and actually multiplied it, right, 2x to the 4th times 6x would give me 12x to the 5th. 2x to the 4th times 4x to the 3rd would give me 8x to the 7th, and 2x to the 4th times the negative 3 would give me a negative 6x to the 4th. Now this is my check. Alright, the reason why it's my check is because if I take my answer that I get when I factor, if I take my answer and actually multiply my answer out, I should get what I initially started with. And if you notice, we did. What we got when we ran our check was the same polynomial that we started with. So again, it's undoing multiplication. Undoing multiplication. Okay? So let's look at some examples. Alright. We have 4x to the 3rd, let's say minus 10x squared plus, let's say, what's a good one? Let's say 12. Let's say 12. Okay. So now we're looking at this trinomial 3-term, wanting to factor, looking to see what we can pull out, looking for a GCF, right? So first thing, like I said, we check coefficients. My coefficients are 4, negative 10, and 12. So what's a factor that's common to 4, 10, and 12? Once again, that would be a 2. So I know I can pull a 2 out. Okay. Now, after I check my coefficients, right? We check coefficients. So after I check my coefficients, the next thing I want to check is the variable. When I look at my variable, I have an x in this term, I have an x in this term, but there are no x's in this term. Because there is not an x in each term of the polynomial, we can't pull out an x. Alright? So basically we're left just having to pull out this 2. And if we pull out the 2, we realize that's our GCF. That's our GCF. So once we've determined what our GCF is, we write our parentheses, and now we're going to write what's left. So basically, if I took this 4 and divided it by 2, I'm left with a 2, and I keep the x to the 3rd. If I took this negative 10 and divided it by 2, I have a negative 5, and I keep the x squared. If I have this positive 12 and divided it by 2, I get 6, and that's it. Okay, so my GCF was 2, and I'm left with 2x to the 3rd minus 5x squared plus 6. And if you notice, if I multiply the GCF times this, I would get that. GCF times this would give me that, and GCF times this would give me that. So that tells me that I wrote my answer correctly. Alright, again, the part that is circled is the answer. Okay, the multiplication I did after that is just a check to see that I did it right. Alright, let's look at another one. Let's say we have 6x to the 3rd minus 12x to the 5th plus 9x squared minus x to the 4th. Okay, so now we have a new problem, new polynomial we're trying to factor. Again, first thing we do is we're going to check coefficients. So I have a 6, negative 12, a 9, and a negative 1. So nothing to be pulled out there. The fact that this is a negative 1 tells me that I can't pull out anything other than a 1 on these, so nothing to be pulled out with the coefficients. So now I check variable. I see I have an x in this term, I have an x in this term, I have an x in this term, and I have an x in this term. There are 4 terms in this polynomial, and each term has an x in it. So the fact that each term has an x tells me I can pull an x out. Now once I realize I can pull an x out, okay, I have to determine the exponent for the x that I'm going to pull out by looking at the lowest exponent of the x's in the original polynomial. So I have a 3, a 5, a 2, and a 4. So 2 is the lowest exponent, alright, the lowest degree here. So we pull out x squared. So now I don't have anything to break down the 6, so the 6 stays. I have x to the third. I pull out x squared, so 3 minus 2 tells me I have 1x left. Then I move to the next term. So negative 12, nothing to be divided by with the 12, so it stays. X to the fifth, x to the second, 5 minus 2 means I have x to the third. Keep my 9. X to the second, I pulled out x to the second, so 2 minus 2 is 0, so I won't have any x's on this 9. And then x to the fourth, x to 2, 4 minus 2 is 2, so x squared left. Okay, so there you have it. That would be your final answer, where your GCF is x squared. Okay, now let's look at another one. Let's say we have 8x to the third minus 4x to the fourth plus 14x squared. Alright, so once again we check our coefficients. Check our coefficients first to figure out GCF. And so I look, I have an 8, negative 4, and a 14, all even. The only number that I know that goes into 8, 4, and 14 is 2. Well, the greatest factor I know 1 goes into them, but the greatest factor other than 1 is 2. So I know I can pull a 2 out, so I check the coefficients. So now I want to check the variable. So I have an x in this one, in that term. I have an x in that term. X in that term. I have 3-term polynomial, so a trinomial, and each term has an x present. Okay, so if I factor an x out of each term, then I can pull an x out, and the lowest exponent present is square, so I pull out 2x squared. So now if I say 8 divided by 2, that's going to leave me a 4. X to the third, x squared, 3 minus 2 means I have x to the 1. Okay, so basically if I said this GCF times what I wrote first, it would give me this right here. Alright, now minus, now I'm looking at the next term, so I have a negative 4 divided by the 2, because those are my coefficients, so that's going to give me the negative 2. I have x to the 4 here, pulled out x to the 2, so the 4 here minus the 2 that I pulled out leaves me x squared. Okay, plus, alright, so now if I took my GCF and multiplied it by this, it would give me that, right? And then the last term, the third term, is 14. So 14 divided by the 2 that I pull out leaves me 7. X squared, the x's would cancel, and that would be it. So if I took my 2x squared, multiplied it by 7, it would give me my last term. Alright, so again, this is the answer. Alright, if I wanted to check my answer, okay, if I wanted to check my answer, I just do the multiplication I have here, and I see that I would get what I started with. This is what I started with. This was the original problem right here. That was the original problem. So if what I factor can be multiplied to give me the original problem, then I'm on the right track. Okay. Alright. Now let's look at a couple other ways to pull out a GCF. They won't always be just a coefficient or a variable. So let's look. Let's say we have something that looks like this. Okay, so this is really a binomial, okay, because really what I'm looking at is one term here plus one term here. So one term plus another term is what I'm looking at. Now most people would want to multiply this because they're so used to seeing something next to parentheses and start multiplying. But remember, we're factoring, and by nature factoring, we want to undo multiplication. So if you started multiplying, all you're doing is making the problem more cumbersome than it should be. Okay, you're working against yourself because we're trying to undo multiplication. So you wouldn't want to start undoing multiplication by multiplying. Alright, so when we look at the two terms, like I say, this would be term 1 and this would be term 2. I know it looks ugly, but you get the point. Term 1 and term 2. Okay, when I look at the two terms, I realize what they have in common is this 3x plus 1. Both terms have a 3x plus 1 in common. So if they have 3x plus 1 in common, just like over here with these problems, we pull out the GCF, what they have in common. Alright, every time we're pulling out a GCF, we're pulling out whatever it was they had in common. So in this case, what they have in common is 3x plus 1. Alright, so after we pulled out what they had in common over here, you notice we always wrote a set of parentheses. We always wrote a set of parentheses. We wrote a set of parentheses, and inside the parentheses we would write what was left. So I write my parentheses, and what I notice is after I pull up 3x plus 1 in the first term, what's left is 6x. So I write a 6x. When I pull out 3x plus 1 in the second term, what's left is the plus 4. So I write plus 4. So there you have it. The GCF in this case is the 3x plus 1, and what's left is the 6x plus 4. And if you notice, if I multiply these two using horizontal multiplication, basically I would take the 3x in the first term to multiply it by 6x plus 4 if I'm using horizontal. Then I'd say plus 1, excuse me, and multiply it by 6x plus 4, okay, which is going to give me the same thing that I have up there. It's just that instead they have the 6x plus 4 out here, okay. Or a better way to do it here, let me do this. I'm going to show you this way so it looks better. So if I took each one of these, so I can take the 6x plus 4 from here and multiply it by 3x plus 1, and I can take the plus 4 and multiply it by 3x plus 1. There you go. And that's exactly what you started with. That would be the initial step for multiplying if you were going to do horizontal multiplication. So again, this is the answer, and this would be my check. See that I'm going in the right direction with my problem. Alright, so this would be considering that our GCF, instead of a coefficient or a variable, this would be saying our GCF is actually a binomial. Okay. Alright, our GCF is a binomial. Alright. So that pretty much takes care of what we want to talk about with GCFs in general. But a fourth thing I want to discuss, or a fourth method of factoring that I want to discuss, okay, is what's called factor by grouping. And grouping is typically used when you have a 4-term polynomial. Okay, a 4-term polynomial. Clean this up a little bit. Okay, a 4-term polynomial. Alright, that's when we use grouping. So, let's see. Let's say we have 15. I'll put this parenthesis on here. Don't need that. Okay, so we have 15 x to the third minus 10 x squared plus 6x minus 4. Alright. We notice, first of all, we look for a GCF. We always check for GCFs. Okay, so I check the coefficients. I have a 15, a 10, a 6, and a 4. 15, only things that go into 15 other than 1 and 15 would be a 3 and a 5. Alright, well 5 goes into 10, but 5 won't go into 6. Alright, 5 won't go into 4. 3 goes into 15. 3 goes into 6, but 3 won't go into 10. 3 won't go into 4. Alright, so we see right here that there is no GCF as it relates to a common coefficient. So then I check for the variables. Alright, well I see that this particular polynomial has the variable x in it, so I want to see if each term has an x. So I look at the first term. The first term has an x. The second term has an x. The third term has an x in it. However, the fourth term does not have an x in it. So each term in this polynomial does not contain an x, so I cannot pull out an x. So that rules out the possibility of pulling out a common variable as my GCF. We don't see any common binomials at this point. So those are the three things we mentioned before for GCFs: common coefficient, a common variable, or a common binomial. Alright, so what we want to use now is a method again called factor by grouping. And with grouping, what we typically want to do is, because it's 4 terms, we just want to group the first 2, write a little plus sign in the middle, and then group the last 2. Okay, group the first 2 terms of the polynomial, write a plus sign, then group the last 2 terms of the polynomial. Alright, so now that we have them grouped, we can actually look to just factor each grouping. So if I look at my initial grouping, I have 5x to the third minus 10x squared, so I can pull out a 5 and an x squared for my GCF, because 5 goes into 15 and 10 coefficient wise, and both terms have an x and the lowest exponent is squared, so I can pull out an x squared. So if I pull out a 5x squared from here, alright, so this being my GCF for my first pair, right, my GCF here, and so I'm left with, if I pull a 5 from 15, 15 divided by 5 is 3, x to the third, x squared, 3 minus 2 is 1, so that's just x, write my minus sign. 10 divided by 5 is 2, x squared, 2 minus 2 is 0, so no x is there. So that takes care of my first grouping. Alright, I write my plus sign, and now I'll look at my next grouping. Okay, over here, alright, I have a 6x minus 4, so I want to think about what I can pull out, and I realize I can pull out a 2 of the coefficients. 2 goes in 6, 2 goes in a 4. Can't pull out an x because the 4 doesn't have an x, so I pull out a 2. So now 2 is going to be my GCF here. So when I pull out a 2, 6 divided by 2 is 3. I'm left with this x right here because I don't have any x's here. And write my minus sign of 4 divided by 2 is 2. Okay, so now I have that. Well, guess what? this phase right here looks just like the problems I just showed you where we're talking about factoring out a common binomial. Okay, because notice basically we have one term here plus a second term there, so two terms. And what do both of these terms have in them? Both of them have 3x plus 2 in them. I mean 3x minus 2, excuse me. Both of them have 3x minus 2, so now 3x minus 2 becomes the GCF because it's a common binomial. Alright, so just like we've done in the past, we pull out our GCF and then we write our parentheses, and in the parentheses we write what's left. Well, if I pull 3x minus 2 out of my first term, then that's all that's left. So I write 5x squared. Now if I look over here at the second term, if I pull out 3x minus 2, the 2 is all that's left. And it's a plus in front of the 2, so I write plus 2. And that's all that's left. So at the end of the day, if I multiplied these two binomials, I would get what I started with. Okay? Alright, so if I multiply those two binomials, I'd get what I started with. And realize again, this part is the answer. This part here circled, that's the answer. Okay? I would just multiply these two binomials to see that I got what I started with as a way to check my answer. Okay? But here, the two binomials being multiplied by each other in this current form, okay, would actually represent my answer to this problem. Now, if you notice, after we group these, the initial polynomial up in the pairs of two, in the pairs, what we factored, when we factored out a GCF of the first pair, what we were left with in parentheses, we got the same thing in our second term. Alright, so by nature, if I'm going to factor by grouping, whatever I want here, whatever I have here, after I pull out a GCF, I need to have the exact same thing here so I can pull it out. Right? I need to have the same thing in both terms in order for me to pull it out down here for my answer. Okay, so going forward, that helps us determine what we want to factor out in our second term. So let's look at another one. Let's look at x to the third plus 2x squared plus 5x plus 10. Okay, again, 4 terms. So 4 terms tells me I may be using grouping. I need to be looking for it. Okay, I look first for coefficients. I have a 1 here, so the fact that I have a 1 as a coefficient automatically tells me I'm not going to be able to factor anything out. Okay, because nothing goes into 1 but 1. So the fact that one of my coefficients is a 1 or a negative 1 in other cases, then you already automatically know you won't be factoring out a common coefficient. Now I look at my variables. I have an x in this term, an x in this term, an x in my third term. However, there is not an x in my fourth term. So the fact that each term does not contain an x tells me I cannot pull out a common variable. Okay, there aren't any common binomials present here, so I can't pull out a common binomial. So I'm left with trying to factor by grouping. So I group the first two. Write my plus sign, group the last two. And let me point out, it is very important that you keep that sign there. It's just a matter of principle and keeping yourself on track. Okay? So try to make a point of keeping the sign in between the two pairs when you do your grouping. Alright, so now when I look to group the first pair, I realize I can pull out an x squared. And if I have an x to the third and I pull out an x squared, 3 minus 2 tells me I have 1x left. Plus sign. I have 2x squared here. Of course my 2 stays because I don't have anything to divide the 2 by other than a 1. So it stays. x2, x2. 2 minus 2 is 0, so no x is attached to my 2 right here. Alright. So now my GCF in this case is x squared. And I'm left with x plus 2. Now notice, as we said before, what we got in parentheses in our first term, we need to get to the same thing in parentheses for my second term. So right now I have a x plus 2. So I know in this next one, when I factor out this next pair, I need an x plus 2 in parentheses. Okay? So again, I keep my plus sign, and I try to figure out what can I pull out of a 5x plus 10, and they both have 5 in common as a GCF. So if I pull a 5 out of 5x, 5 divided by 5 is 1, and I keep my x, so 1x. 10 divided by 5 is 2. And as you see, x plus 2, x plus 2. So there's one term, there's a second term. Remember, terms are separated by pluses, or pluses and minuses, depending on how you want to look at it. So this is one term plus a second term. Now, what do these terms have in common? Both of these terms have x plus 2. So I can pull out x plus 2. And if I pull out x plus 2, I have to write what's left. And what's left is written in parentheses as x squared plus 5. Okay. This would be my answer. And once again, if you multiply these two binomials, you should get your introductory polynomial. Alright, let's do one more. Let's say we have 2x to the third minus x squared minus 10x plus 5. Okay, we have this one. Check all our coefficients. By having a negative 1 right here, we know we can't pull out a coefficient. Check our variables. Our 5 doesn't have an x, can't pull out a variable. No coefficients, no variables. Check. No common binomials. Alright, remember, this is what we mean by a common binomial. X plus 2 here, x plus 2 there, those are common binomials. Don't have that situation right here, right now. So we go ahead and group 2x to the third minus x squared. Write our plus sign. Notice I wrote a plus sign regardless of what the sign was. And I keep the signs attached to the coefficients inside of parentheses. So at this negative 10, I didn't write a minus and then the 10 right here. I wrote the negative 10x, excuse me, it should be a negative 10x. Negative 10x plus 5. Okay. I kept that negative with that 10 inside of the parentheses. Now I go to factor. I can pull out x squared out here. That leaves me with a 2x minus 1. Right? Because x squared times 2x would give me 2x to the third. X squared times negative 1 give me a negative 1x squared. Alright, now we've said how whatever we get in the parentheses here, we need to get the same thing when we factor the second pairing. Okay, but if I notice I want a minus sign in the middle, I have a minus sign in the middle here. So in order for this second pairing to give me the same factor, I know I need a minus sign in the middle here, but I don't have it. So when I look to factor the second binomial, I just tell myself whatever I would normally pull out, I would just need to pull it out in the negative version. So if I looked at these, normally I pull out a 5, but because I know I need to change the sign in the middle, instead of pulling out a 5, I'm going to pull out a negative 5 or a minus 5. And when I do that, now negative 10 divided by a negative 5 gives me a positive 2x. Right? Because a negative divided by a negative is a positive. 10 divided by 5 is 2. Keep the x. And now I have, excuse me, let me change that. And now I have a positive 5 divided by a negative 5. Positive divided by a negative is a negative. And 5 divided by 5 is 1. And now you see 2x minus 1, 2x minus 1. There's one term minus another term. Okay, so they both have 2x minus 1 in common, so I pull that out, and what's left is the x squared. So I write my parentheses, and what's left is x squared and the minus 5. Okay, so that's my answer. And if you multiply these two binomials, you should get that 4-term polynomial right there. Alright, Okay, so this pretty much wraps up everything that we want to cover in just the basics of factoring. Again, we want to look to pull out common coefficients, common variables. If you're going to pull out a variable, remember it's to the lowest exponent that's present in the polynomial, and that variable has to be present in each term of the polynomial. We've talked about pulling out a common binomial, which is basically what we see here. Common binomial, pulling out a common binomial. Okay, and last but not least, we talked about factor by grouping, and what typically tells us we're going to use grouping is that the initial polynomial that we start with is 4 term. 1, 2, 3, 4 term. Alright, 4 term polynomial to start, and we basically break it up into pairs. Alright, so that concludes this session. We will continue with factoring of quadratics in following sessions. Thank you.